Okay, the way that I saw to do this one is that the bottoms, the denominators here, are factorable. So if you do that, you get x plus 2 over, this one is x minus 2, x minus 1, minus x minus 6 up here, and this one is x minus 2, x minus 3, equals 1 over x minus 1. So I'm going to get rid of this. So I'm going to get rid of that denominator on the right real quick. And to do that, I'm going to multiply both sides by x minus 1. So over here, you're going to multiply everything by x minus 1. So that gives you x plus 2 times x minus 1 over x minus 2, x minus 1, minus x minus 6 times x minus 1, x minus 2, x minus 3 equals 1. Right, so that's gone. It's kind of like if you had, let's say I had 12 over here equals 1 over x, and I multiply by x, multiply by x. I have 12x equals 1, right? That's the same thing, but just longer, basically. All right, I'm gonna change color again so you can keep up with what I'm doing. So now I just noticed that this has an x minus 1 and an x minus 1, so that cancels. Nothing on this side can cancel out top and bottom. But if we can keep this in factored form for a little bit, we can solve it a little bit easier. So now I have x plus 2 over x minus 2 minus x minus 6 times x minus 1 over x minus 2 times x minus 3 equals 1. So on this side, I'd like to get a common denominator since I'm subtracting, and that's real easy now that I see I have an x minus 2 and an x minus 2. The only thing I have to multiply is x minus 3. So this one's going to get a multiplied by x minus 3 over x minus 3. So that gives me x minus 3 times x plus 2 over x minus 3 times x minus 2. And then minus x minus 6, x minus 1 over x minus 2, x minus 3. So now I have that common denominator so I can add those fractions. So I just keep changing colors for you so that you can keep up with what I'm doing here. So now these can be combined because we have a common denominator. So we can write it as one big long fraction over x minus 3, x minus 2. So at the top on here, I'm going to go ahead and distribute it out so that I can combine like terms when I get everything together. So that's going to give me x squared minus 3x plus 2x minus 6 minus x squared minus 6x minus x plus 6. Okay, still equals 1. So now that minus gets applied to everything in here. So it's going to be minus x squared plus 6x plus x minus 6, right? Because this minus out front goes to everything there. So now we can go look for like terms. So I have x squared minus x squared. That's gone. I have a minus 3x plus 2x, which is minus 1x. And then a plus 6x plus 1x is a positive 7x. So minus x plus 7x gives me a 6x. And then, so now my x's are all done. I'm just crossing out because I already did it, right? This is gone. Now I have minus 6, which is minus 12. All right, and that's still over this x minus 3, x minus 2. That's still what it's on top of. So if I then multiply this whole thing, multiply by x minus 3, x minus 2. Multiply this by x minus 3, x minus 2. So that's gone. And you have 6x minus 12 equals x minus 3, x minus 2. And I can like recognized for myself that if I factor out a 6 here, I have x minus 2. And then I have x minus 3, x minus 2. Well, then I can divide this side by x minus 2, and then you get, got to do the same thing on both sides. And guess what? You get 6 equals x minus 3, and x equals 9. Now, the book stopped like that. They went to right here, and they expanded this side out. And that ends up giving you two solutions of x equals 2 and x equals 9. But x equals 2, when you plug back into the original problem, is not a valid solution. It doesn't work out. So if you keep going in that factored form, you end up with this x equals 9. So that's the final answer.